Greetings, hello, welcome back. Let's finish where we left off in the previous video. Okay, we were solving this problem. We're finding the tension in the wires as well as the speed at which the tension is the same in the wires. So let's continue, shall we? Okay, so solve equation 2 and 1 simultaneously. Alright. Okay. We have T2 cos theta plus T1 sin theta is equals to mv squared over L AO. Let's do it here. T2 cos theta plus T1 sin theta is equals to mv squared all over LOA. This was our equation 1. Equation 2 was T2 sin theta plus T1 cos theta. All of this was equals to mg. This was equation 2. Let's just confirm it. LAO. Okay, cool. Okay, that's to the power 2 there. Alright, so let's solve this. What we'll do is multiply this equation 1 by cos theta, and I'll multiply equation 2 by sin theta. If I do that, what happens to equation 1? Equation 1 becomes T2 cos squared theta plus T1 sin theta cos theta is equal to mv squared over LAO. So that was AO cos theta. So this becomes equation 3. Name it equation 3. And equation 2 becomes T2 multiplied by sin theta. This is sin squared theta plus T1 sin theta cos theta is equal to mg sin theta. This is equation, let's name it equation 4. So let's subtract equation 4 from 3. Then say T2 cos squared minus T2 sin squared T2 open bracket cos squared theta minus sine squared theta. Right. T1 sine theta cos theta minus T1 sine theta cos theta. This and that one are the same, so if we subtract these two, it's the same thing as 1 minus 1, so that's 0. So plus 0 is equal to mv squared over L AO cos theta minus mg sine theta. Right. Nice. Okay. This we can use double angle. We can use an identity to solve this. So we can use math to help us solve that. There is an identity that states that cos squared theta minus sine squared theta is equivalent to cos 2 theta. So all that is equivalent to cos 2 theta. Okay, 2 theta, 2 theta. Alright. So this becomes T2 cos 2 theta is equal to m v squared over LAO cos theta minus mg sine theta. Alright. Okay. Can simplify it further. It becomes T2 is equal to m over cos 2 theta multiplied by v squared over LAO cos theta minus g sine theta. Alright. And we'll call this equation 5. Alright. Cool. Now let's do the same process, only now we'll multiply. Only now what we'll do is we'll multiply this one, we'll multiply equation 1 by sine theta, and we'll multiply equation 2 by cos theta, and do the same thing and do the same operations, and then solve for T1. T2 cos theta. Okay, write it down here. T2 cos theta plus T1 sin theta is equals to m v squared over LAO. This was equation 1. Equation 2 was sin theta plus T1 cos theta is equals to mg. This was equation 2. Now multiply this one by sin theta and cos theta. By sin theta, this one by cos theta. It's almost the same, but it's just we're changing, we're multiplying. we're alternating the equations, so we're swapping the equations. What I mean by that is, in our previous operation, we multiplied equation 1 with sine theta. With cos theta, and we multiplied equation 2 with sine theta. Now what we are doing is the opposite of that. We're now multiplying equation 1 by sine theta and equation 2 by cos theta. Okay, cool. So let's go ahead and do that. T2 cos theta times sine theta cos theta sine theta plus T1 sine squared theta mv squared over LAO sine theta. This one becomes T2 cos theta sine theta plus T1 cos squared theta is equal to mg cos theta. Alright, let's name this one equation. How many equations do we have now? Okay, this was equation 5. So we can name that one equation 6 and 7. Equation 6, name this one equation 7. Alright, let's go ahead and subtract 7. Let's subtract 7 from 6. No, let's subtract 6 from 7 instead. 6 from 7. So 7 minus 6. Okay, so T2 minus T2, this will be 0, plus this one minus that one. So that will be cos squared theta minus sine squared theta. So T1 outside the bracket, cos squared theta minus sine squared theta is equal to mg cos theta minus this one minus that one. Don't get confused. It's 7 minus 6, okay? 7 minus 6. Mg cos theta minus mv squared over LAO sine theta. Cos squared theta minus sine squared theta, that is the same thing as cos 2 theta. So this equation reduces to T1 cos 2 theta is equal to mg cos theta minus v squared over LAO sine theta. Alright, this is starting to look like our previous equation. Making T1 subject of the formula, we end up finalizing this guy. We end up with T1 is equal to m over cos 2 theta multiplied by g cos theta minus v squared over LAO sine theta. Alright, call this equation 8. The question was asking for us to find what is the velocity when T1 is equal to is the same as T2 and the tension in the wires are the same. So this tension is that, so M cos 2 theta multiplied by V squared over LAO cos theta minus G sin theta. And that, so T1, need to find out T1, we need to find out the value of the velocity when T1 is equals to T2. Okay. So this is the value of T1. We can write T1 as, okay, just write down T1 as it is, cos 2 theta V squared over LAO cos theta minus G sin theta is equals to, what is the value of T2? T2 M over cos 2 theta G cos theta minus V squared over LAO sin theta. Right. Okay, from here you can already see that this one and that one are the same, therefore they cancel out. And that leaves me with just V squared over LAO cos theta minus G sin theta, which is equals to G cos theta minus V squared over LAO sin theta. Okay. Alright, in this case just collect like terms. Can collect like terms here. Collect like terms. Say V squared over LAO cos theta. Check this one is also on the other side. Becomes plus V squared over LAO sin theta. Take this one, that side becomes G, say cos theta plus G sin theta. Alright, take out V squared from here. V squared with a common denominator, therefore I have cos theta plus sin theta all over LAO is equals to G. Take out G, it's common, cos theta plus sin theta. Alright, from here you can already see that cos theta plus theta is common there, so that will fall off. Then we just have in the end V squared is equals to G L A O. Therefore, V equal to square root of G L A O. So that's our velocity when the tension in the wires is the same. So this will give us this velocity. So let's evaluate it. To evaluate it, we'll just substitute the values. we'll take G as 9.80 and LAO, we found that one to be what? What was LAO? Just quickly look for it. LAO, where are you? Where are you? LAO. Okay. Okay, from the geometry, LAO. Just make sure. Okay, didn't evaluate it. No problem. So from our geometry right here, LAO is this one. We know LBA, therefore, well, this is 30 degrees, so which is the same as phi. Phi is 30. Therefore, we know LAO. We can get that one. LAO is equal to LBA cos theta. Cos theta. This is the opposite, and this is the adjacent. Therefore, that is cos theta. One cos 30 degrees, which is equals to square root of 3 over 2. Okay, square root of 3 over 2, that is 0. 0.8 something. Okay, square root of 3 over 2. Alright, 0.866. Alright, cool. So that's 0.866 meters. Take that to where we are working, and then we'll be done. So square root of 3 over 2, or if you like, you can use 0.866. 1.80, 0.866. That should give you, this should give us 2.91 meters per second. Alright. If we have this, we can also, so this is the answer to question A. We can also evaluate now with this, we can evaluate the tension in one of the wires and then just equate that to the other wires since the tensions are the same at this point, at this instance. Okay, cool. So T1, the mass 2.2 kilogram. Okay, right by cos 2 theta, that is 2 times 60, 9.80 cos 60 minus 2.91 squared over 0.866 sine 60 degrees. Okay, this should give us 14.35, 14.4 newtons is our answer to B. Alright, there you have it. That's our answer. We have 2.91 meters per second, and we got tension 1, which is equal to tension 2, as 14.4 newtons. Alright, thanks for watching. Please like the video, subscribe, and share with your friends.